Welcome and thank you for attending our webinar, Automotive Maintenance and Light Repair, with our author, Luke Thompson. My name is Josh Carlson, and I am the Market Development Coordinator at GW Publisher. GW provides print and digital resources for career and technical education, with a full line of titles across the transportation pathways. A few housekeeping items today for the webinar. You are in listen-only mode, but we want to hear from you. Please be sure to add comments, questions, or ideas in the chat box, and we will spend time at the end of the session answering questions, and I will be monitoring the chat throughout the session, and we can answer them during the Q&A. Before we get started, we're going to launch a poll to see what state everybody is in. So as that is launching, it should be coming up on your screen. But we are so excited to have our author, Luke Thompson, with us today to discuss his solution for MLR programs, maintenance and light repair technician, and a newly updated resource for mastering crucial math skills for transportation programs, math for automotive technicians. Near the end of the webinar, you'll have a chance to let us know if you want a print or digital sample if you haven't received one already. Maintenance and light repair technician will be submitted for the next Florida CT adoption for your automotive maintenance and light repair 1 course. If you are a Florida educator, our editors have ensured that this title will meet your Florida standards and learning outcomes, and the book is already assured around the ASD Education Foundation task list for MLR certification, which is the approved certification on your CAPE list. And a little bit about our author. Luke Thompson is an author of GW's innovative digital hands-on maintenance and light repair technician suite and math for automotive technicians. Since early 2018, Luke has been a technical training instructor for Tesla Incorporated. Previously, Luke taught for over a decade as a secondary auto technology teacher in Michigan and Washington. Throughout his teaching career, he achieved MLR accreditation for the schools where he taught. Luke also served as an evaluation team leader for ASC and received the ASC Industry Education Alliance Outstanding Instructor Award. Luke earned his associate's degree in automotive technology from Henry Ford Community College, his bachelor's degree in secondary CTE from Wayne State, and his master's degree in curriculum and instruction from the University of Washington. Luke also holds various ASE certificates, including Master Certified Automobile Technician and Hybrid Electric Vehicle Specialist. Prior to his teaching career, Luke worked as a prototype technician at Ford Motor Company's Research and Development Division in Dearborn, Michigan. Before I hand it over to Luke, we're going to launch another poll asking how long everybody has taught. And once that launches, that is launching. And now, Luke, it's all you.
All right, well, good afternoon. I'd like to welcome all of the instructors and teachers to this webinar. I'm really excited to have the opportunity to talk with you today. I'm coming to you from Austin, Texas, where, as Josh mentioned, I do work for Tesla, and I've been working with them for almost 7 years now. But my career started off, my automotive career really started off when I was a student in a high school auto shop program. And it was going through that high school auto shop program as a high school student that I was inspired by my instructor at the time. And he said to me when I was a student, we had the auto shop, but we also had welding shop and machine shop. And he kind of taught all of those different shop classes at this school near Detroit in Michigan. And he said to me, he said, you might not believe me right now, but someday you're going to make a great auto shop teacher. And I didn't believe him at first. And I left high school and was studying automotive and going after different automotive related careers, hobbies, all kinds of stuff, doing several different things related to the automobile. And then finally I realized, Mr. Wright, he was right about that. I probably should look into this career for becoming a teacher and becoming an instructor, because I really do think that that's something that would work out for me. So I pursued that and was able to get a bachelor's degree in education and start teaching. And I started doing that actually at a pretty young age. I started teaching high school auto shop, and went through a great program, a career and technical education program that prepared me to become a high school auto shop teacher. And that's really how my career got started. But looking back on that, what I realized when I first started my career as a teacher, I was pretty bad as a teacher. I did actually a pretty terrible job, and at first. And what I learned from that was I was trying to create an environment that was just not going to be possible for that high school auto teaching program. And I was trying to go too far, and it was too theoretical. And I was trying to like really, really go to the extreme with all of that knowledge and information. And what I learned early on in my career, my teaching career, was that it was going to be best for me to try to meet the students where they were, instead of me trying to get to some other unrealistic point. And so what that took on my part was for me to make this change in the way I taught, to be less theoretical and to go more hands-on, and to allow the students to work more in the shop, learn more in a hands-on environment, learn how to really use the tools, use the shop equipment, and really get lots of hands-on practice and be comfortable as a teacher in that environment, and to sort of really shift my bias from the classroom and theoretical teaching to in the shop, and then find ways to do what now I refer to as a fender side lecture, right? Where you're actually getting your students and your classes into the shop more. So that's what I learned after really struggling early on in my teaching career, was that was going to be one of the things that I was going to have to do was shift the way that I approach teaching from that theoretical based, and get a lot more, hands-on in the shop and get comfortable with that. Problem was that was really tough to do. You gave up a lot of control over your classroom. The students had a lot more freedom. The other thing was the students, they couldn't all be doing the same thing at once, because you have a large class size. So you have to find ways to have lots of different activities for the students to be doing. And that was not easy to do. That was challenging. And to have all the tools and all the equipment, everything set up for the shop to run well, where the students are using the shop a lot more and the classroom less. And so that was something that was a big challenge. And then about 10 years ago or so is when the publisher, Goodheart-Willcox, reached out to me and started talking to me about, like, what do you do? How do you teach your class? Because I had tried when I first started teaching, I had several different textbooks, I had different curriculums, I had some of the stuff, but I found that I was having to still build a lot of stuff myself. And I was, building curriculum myself to try to like find this way to get the students blended into the shop more and things like that. And how much of a challenge that was. And so when Goodheart-Willcox called and they started talking to me, and they were asking, well, how do you do this? What do you do? And so we started really getting into some of these, like, philosophical conversations about how do you like build curriculum that helps empower teachers and educators to get their students into the shop more. And from that, we sort of flushed out this project that was originally called Hands-On MLR. And it was essentially this like really deep dive into hands-on practical lessons that could be done throughout the entire maintenance and light repair MLR task list. And so that's what we did. And that is what sort of started off as the Hands-On MLR program, which was originally 60 different hands-on lessons that were the textbook really was designed to go along with and to be part of this like computer-based program where the theory that the students needed was side by side with the hands-on practice that they were doing. And this comes back to the thing that I still continue to to go through and to preach all the time is that, training in this type of environment and really across the entire career and technical training spectrum really has to have a hands-on approach. It has to be a hands-on training process. And even today, so my career now is working at the Gigafactory in Austin, Texas for Tesla. I started out there as the first technical trainer in that building about 2.5 years ago. So I brought technical training to that facility when it was still smaller and they weren't building as many cars and stuff like that. Now the technical training team consists of 12 instructors that we provide technical training for almost several thousand technicians. And it's not just vehicle repair technicians or quality inspection technicians. It's also maintenance technicians. And that's something else I'll talk a little bit about later. But the maintenance technicians, they are the technicians who fix robots, fix conveyance systems, fix, light curtain access systems, HMIs, right? Human machine interface systems. They're the technicians that do all of that work. And so we provide all of their training for them throughout their entire career, from entry level technicians all the way up through master level technicians. And so it's a big responsibility, but we have to develop all of our training and curriculum materials for that program. And everything we do is biased towards a hands-on approach. That is because everything that they do in their job is very hands-on. Programming a robot that has a welding end tool on it that's going to be welding sheet metal together for the body of a car, that is all hands-on. Fixing when you have a car that can't pass the final quality inspection because of some issue, fixing that, diagnosing that is all hands-on. So everything that we do has to reflect the job. And that's also a big part of adult learning theory. In order for adults to buy into adult learning theory, it has to relate back to what it is that they're doing and what they're asked to do for their job. And I think that really does apply to career and technical education as well. When we're trying to teach our high school students or our college entry-level students the stuff that we want them to learn, the best way we can get their buy-in is to show them how it relates to something that they're going to have to do in their career and in their job. So this is a very hands-on role. When you go visit dealerships, when you go to visit shops, I mean, everybody that's working in the shop is doing a very hands-on job. So because of that, the training really needs to get the students to do as much hands-on practice as possible. So that was the main big lesson that I learned when I first became an instructor. And that's the same lesson that I've continued to mentor new instructors. As mentioned earlier, I did also work as like an evaluation team leader for NATEF. And so there were several schools that I went and visited where I would meet with the instructors there to do their evaluation, to make sure they were meeting all those standards. And that was definitely a big conversation that we always had was, does your program provide enough hands-on training? Are the students practicing it enough hands-on? So that was the thing that we did. And so when I started working with GW, that was the thing that I stood strong on, was everything we're going to do, it has to have a hands-on component. We have to show ways, we have to help empower these instructors so that they feel comfortable getting out there with their students in the shops, getting them to work hands-on and to be able to do, get the practice, get the repetition. We know, those of us that are working with entry-level students, young students, high school kids coming through, that in today's day and age, most of them are having less and less previous experience. They're coming to us with less and less previous knowledge and previous experience about using tools, how things work, how machines work, things like that. I know from my childhood growing up, I was in the garage a lot. I was using tools. I was taking apart bicycles, taking apart lawnmowers, putting that stuff back together. I was tinkering with things like that. That is something that I think, across the board, we see less and less of, is that our students are coming to us knowing how to use tools, having those skills and having practiced taking things apart, putting them back together to where they still work, things like that. So because of that, we really have to get them into this hands-on environment. And so because of that, this is what we've done when we've built out these products, the MLR suite especially, is that we have all of these lessons that build and put the theory side by side with some hands-on training prompts to help walk you through what that's going to look like. And we've done it in a way that makes it generic enough that it can adapt to whatever environment you have in your shop. And that's for the MLR Technician Suite. For the Math for Auto, we took a different approach there too, because we looked at just some of the standard math books that had been written in an automotive flavor. And we said, you know what, this doesn't apply as much as it should. And how do we make a automotive math textbook apply to the real world that we're doing? And the best way to do that was through case studies. And so the first thing we did is I worked with several different math instructors that I knew, and we sort of figured out what were the 12 best math concepts that we needed to teach, mathematical and arithmetic style concepts that we needed to teach. We figured out what those were for the appropriate level for a high school automotive program. And then what we do is we take those 12 math concepts and we scaffold them through all of the different ASE automotive study areas. So we have a chassis set of case studies where there's 12 case studies, and those 12 case studies cover the 12 different mathematical and arithmetic style areas. And so we move through all chassis related case studies for those. And then we move on to engine repair and have 12 scaffolded case studies using different math concepts through that. So we'll talk a little bit about both of those projects in a little bit more detail, but the main thing that the way that I'm developing the training and developing the work that I put into these textbooks is to help empower instructors and teachers to get to that hands-on training portion so that they can feel comfortable getting their students out into the shop and working on that. Josh, go ahead and move to the next page here. So we are now on to the second edition of Math for Automotive Technicians. This in the picture here, that's actually one of my former students, high school students, Jordan. He went on to do the Ford Asset Program at a local community college back in Washington, and then ended up with a very successful career in a Ford dealership. And so that was one of the things. But one of the things I should point out right here, because Jordan is an example of this, and one of the things that I have done through all of the textbooks that I've put forward so far is included the technician profiles. And with the technician profiles, this is actually probably one of my most favorite things to do, and that is to interview these younger technicians who are newer in their careers but have had a chance to spend some time out there in the industry, talk to them, ask them questions, and figure out, like, what's your experience like? What has your experience been like as you left your training program, started to work, all of those things, and then put together some, a nice career profile that I can include throughout the textbook. And what I like for that is that when the students who are using the textbook are going through it, they start to see themselves in that career. They start to see, younger technicians who look like them, who maybe have some answers like them. I ask in these technician profile interviews, I love to ask things like, what's your project car? Because every good technician has a project car, right? And so I ask, what's your project car? And they just love to talk about their project car, as most instructors would know. Any student out there that has a project car is going to love to talk about it, probably more than we want to hear. Same thing, like, what are your favorite tools to use? Stuff like that. So I like to really engage them in a conversation, but it really starts to bring out, and they start to get comfortable, and they talk to me about their experience of becoming, an automotive technician and how they've found their way in this career path. So anyways, we've updated the math for automotive technicians. We've got some pages here that show some of the updates, so we can go through those. So as mentioned, we have different case studies that are related to each of the different areas. One of the things that we did was we split up two of the units, or one of the unit we split into two. So now we have an entire unit dedicated to thermal systems, and then we have a separate full unit that's dedicated to high voltage. And so under high voltage, that's definitely become one of my specialty areas, as I've participated in working at Tesla and working with the electric vehicle side of things. There's a lot of fascinating things that goes along with that, and so we've decided to have an entire unit now dedicated to high voltage and electric vehicles. And so we've got 12 case studies that cross those different mathematical and arithmetic areas that we talked about. But these 12 new case studies sort of help introduce instructors to this side of the industry as this part of the industry emerges. And so if you go back, I think 2 slides, Josh. What I want to show here is some of the ways that this is laid out with our case studies, but go back one more if you would, please. You'll notice there's a career profile there. Yeah, so this page, this is good. So unit 1, we review the basic math skills, which you can see here. Go forward one more there, Josh. Yeah, this page. So these are the 12 different math concepts that we have that we scaffold through, starting with addition and then making our way all the way through analyzing specifications, measurement, formulas, graphs, tables, all of those types of things. So those are the 12 different math concepts, and then we repeat all 12 of those math concepts in each of the different case study areas. And then we tie them directly back to extremely relevant parts of the training that you might already be teaching. So if we look at this, say, and we're talking about maybe the chassis unit for this math textbook, the way that I see instructors using this is, if you're going to be teaching a little bit about brakes, right? Then during your lesson about brakes, you can spend maybe 5 to 10 minutes of your teaching and go to the math case study that's related to maybe brake pad percentage calculations, right? And then you teach that, and then the students can work through some practice problems in brake pad percentage calculations, and then they can move on from that. And they don't have to spend an entire hour going through all these different types of math problems related to brakes. It's broken up into we have 108 different case studies. So it's broken up into all of these little small, almost like micro-learning type formats that you can then use to then take whatever it is that you might already be teaching in your normal automotive program, and then just pull in that little bit of reinforcement of, okay, since we're learning about brake pads, we're going to spend 10-15 minutes and we're going to go through these couple of case studies on brake pad calculation. We're going to do that, and then we move on, and then we go do other stuff. And that's the way it's set up to work, is that you can just sort of build it in when you want to use it based on the lessons that you're doing, and then you can move on so that you're not spending a long amount of time just going through math with your students. And like I said, there's 108 different case studies, so we really cover across the board everything that you could possibly come up with that's related to automotive that has some sort of a math concept to it. And so that's what we wanted to share with this one. There's tons of practice questions, and then also practice summative assessments that you can include. But this is something that will help you demonstrate your relevance to the academic side of your students' career as well. So you can show ways that your class is reinforcing some basic math skills and doing that. So this is, I'm really excited about this. I'm really happy for the second edition revision. And I'm really quite proud of this one because I think that there's a lot of really positive work that teachers can use this for with their students. So we can go ahead and let's move to the next page, Josh. Yeah, so on this page, we can see there's an example of a few different things. There's the career profile, which is a write-up about somebody that I interviewed in their career, as well as a photo. And then, you can see there's like images showing something with the air compressor clutch gap, which is something that students would have to do. A measurement that they may have to take using feeler gauges and then determine, calculate wear, stuff like that. So that's an example of the way that we have it so that it is directly tied to things that you will be teaching when you're going through your training. All right, Josh, go ahead and go to the next page. Also showing in this example, air conditioning gauges, another thing that students have to learn how to accurately read and then compare that to a chart to help diagnose, whether the pressures are showing whether there's faults in the system, things like that. So again, really practical stuff. You can literally teach this from a math perspective, and then you can have a car set up with gauges in your shop, and you can go right from teaching this out to your shop where you actually have gauges set up, and you can have the students monitor and take this directly to a hands-on practical approach. So next page, please. Okay, we did talk about this already, the electric vehicles, and that's something that we've added that's new to this edition. Next page, Josh. Yep, this is a new tool that might be new for some people that aren't familiar with doing high voltage testing, essentially isolation resistance on high voltage systems. So that's something new that we've incorporated into this, which is a good new skill and a good new diagnostic tool for technicians to start to learn to use. Go ahead to the next page. All right, so that does cover our overview of the new concepts and additions that we've made to the math textbook. The next one that we want to talk about is the Maintenance and Light Repair Technician Suite. And this has several components to it. It does include a full textbook, which is available in print as well as digitally. And that textbook is basically the complete full source of information for all of these different concepts. And then we also have added to it the suite program, which is sort of an updated version of the hands-on MLR that really helps bring the different hands-on lessons and the theory and the hands-on practice side by side. So this here is a good overview of the different units, which, like any product, is going to easily reflect the NATEF or education foundation different content areas that you find across automotive. So you can see that's the way it's laid out. This does show a picture of a video example, but then on the bottom image here is showing what I was talking about there, which is there's theory and there's like information on the same page as you notice a green, yellow, red, like checkbox lab activity. So the students, when they're going into the shop, when they're going into the lab, this is what we found, is that we were able to if we bring those two things together and basically put them side by side, the theory, the content, the information that they need side by side with the checklist of what they're doing on the vehicle. So this one happens to do with serpentine belts, and they're doing inspections for serpentine belt wear and damage and things like that. So they have the information on the left side that they need to know what it is that they're looking for. And then on the right, they actually have their inspection check sheet that they're going through and marking off green, yellow, red, or non-applicable, right? And so if they're not sure, they can reference the materials on the left, and then they can make a decision as they go through their hands-on lab activity on the right. And so that's how we blended these two things together, was we literally put the same information that they need for both things on the same screen, side by side. Josh, go ahead and go to the next page there. The textbook also has really good images that show all of the important things that they need to be able to do, examples of that. And what I've observed in doing this is that the images with the captions is probably one of the first things that students are going to read when they look at a page. And so we really want to make sure, and we've got a lot of really good images in place with captions that help provide that information. Josh, go ahead and go to the next page. We also have, this is a good example of a spark plug inspection procedure. And so we do have a lot of different procedure breakouts that show how to do at a certain level, how to do some of these basic procedures, including images that share some of the tools that you would use. There's a spark plug condition chart. So we've got information like that, resources available for students to show things like that. Also, proper tool usage using a torque wrench at the end, things like that. So we want to make sure we're showing all of that. Go ahead and go to the next page. Here we've got some of our features that are included in the book. And this is one of the things that I do like to talk about. We've got one of our features that we include that I thought was really important that we include is smartphone tips and tricks, right? And, the idea around phones and phones in classrooms and phones in schools, I know is one that there's a variety of different opinions and reasons behind that I do understand on. What the perspective I take, and especially regarding phones with our students in our shops and things like that, is what I've found in my time is that it's our responsibility to show good habits and best practice for using the device in a productive and meaningful way. And so that means, if you use the phone to look up, say maybe your shop uses the AllData shop manual lookup system, right, or something like that. If you're using that and you're showing that this is a good example of a way to use that, is by using AllData to look up and use that on your phone, because that's the closest piece of technology that you have that's going to help you. That's a good example that we can share with our students. Most of you are probably, see this a lot as an instructor, where students use their camera and they take pictures of certain things on their car, and then they bring you their phone and they're showing you either a picture or a video of, maybe the video of their engine running and it's making a funny noise, and they're like, what is this? Why is it doing this? Or, pictures of different things, or a picture of some sort of component that they're not sure of, or something like that. So I think if we, as instructors, as sort of the, adults in the room, if we use and demonstrate good habits for our students as to, these are some productive ways to use your device to your advantage in this environment, then I think that's one of the things that we can do. And so that's why throughout the textbook, I try to incorporate these features that show things like, tips and tricks related to using your smartphone. So an example here, right? Your serpentine belt routing. We all know that most shop manual systems will have some sort of a diagram that shows us the way that a serpentine belt is supposed to be routed in order for us to put a new belt on and get it in the correct position. But if a student has their phone there, they can take a few pictures of it, maybe from a few different angles before they take it apart, before they take that belt off. And then that's going to help them when they go to put the belt back on to compare it to those photos, things like that. The same thing with wire diagrams. I'm still pretty old school on wire diagrams, and I still love to print out a paper copy of a wire diagram and then, break out the colored pencils and still draw on it to show this is the way it goes. But sometimes we're not able to do that. So having, phone images of wire schematics is going to help us as well. All right, Josh, the next page. Another one that we talk about as feature in the textbook is habits of a successful technician. And this might be a good spot. One of the questions that I usually like to ask whenever I'm talking with a group of instructors is, when as an instructor, when you're going out into the industry and you're meeting with maybe shop managers or small business owners who run a shop, or people that are hiring, or maybe if you're teaching at the high school level and you're talking to some of the college level instructors who are getting your students, what is the biggest challenge that these people face with our entry level new students? And so that's something that we're actually going to put a question in the chat. What do you guys as instructors see when you're out talking to your industry partners, talking to shop owners, service managers, things like that, people who are trying to hire entry level for this automotive career? What is the biggest challenge that they are facing now from those when they make those hiring things? So that's a question that we're going to ask, and that's something whenever I meet with groups of automotive instructors that I like to ask and I like to talk about. But one of the features, while you're answering that question, I'll talk about this is, the habits of a successful technician. We all know there's a lot of, stuff out there about like developing good habits and how do we do that. And then good habits help lead us to being good employees when we work in the industry. So we added these habits of successful technicians. And it talks about things, the examples we have here are something like introducing the concept of foreign object debris and making sure that if students say drop a tool or drop a fastener, that they actually retrieve that and they don't just leave that down, wherever it fell, just be like, well, we have more of those bolts, we'll get another one, and they just leave it behind. That's not a good practice to follow. So we want to make sure we call stuff like that out. We make sure that they're used to that. Another one is, vehicle fluid consumption. We want to make sure that, a student understands that a lot of the vehicle fluids, if they're low, that indicates there's an actual problem that you need to solve. We don't just add it because, a vehicle shouldn't just be consuming that fluid somehow. So that's another thing that we brought up. Some of the other features that we have, which we have on the screen now, are some hybrid or electric vehicle specific features that we've called out, as well as some applied science features. As we all know, when we're teaching automotive technology, we're teaching a lot of physics and chemistry. So we are crossing over into that science world all the time. And so one of the things that we've added here as features is applied science features that talk about different things that they might learn about and also see in their science class. This example happens to talk about thermal expansion and how things change, as they heat up. And then of course, it wouldn't be a textbook without having all kinds of safety first type features. And so we've got those. We do Obviously, we're doing everything we can to meet and exceed the standards set out by the ASE Education Foundation, and that includes ASE style questions. And so we definitely have a wide range of those, not only throughout the textbook, but also throughout the extra features that we provide through the instructor resources, additional test questions and things like that. And I think the next page, so going back to the test questions, one of the things I want to share, it's not on the screen, but we also have our diagnostic scenario questions. And those questions, we have those at the end of each section, and they're questions that are specifically asked from a diagnostic mindset or standpoint, which helps try to get the students into a problem-solving mindset. And I don't know if some of you may know Scott Brown. He's the founder of the AITN and also now the founder of Diagnostic Network. He's also a Goodheart-Willcox author, and he's doing a lot of stuff on the ADAS front. And he's is also a shop owner and a speaker. You may have heard him speak at some of the different conferences and things like that. But I work really closely with Scott Brown. He's a wealth of knowledge. And one of the things that he did was he actually helped out with our diagnostic scenario questions. And what we did was we sat down, Scott Brown and I sat down, and for every single diagnostic scenario question in the entire textbook, I asked Scott the question, and then him and I had about a 2 to 3 minute conversation answer for every single question coming from his perspective as a master technician with, you know, a ton of experience. And so we recorded those as audio files, and those are actually available in the instructor resources as an audio file that you can play for your students or that they can listen to on their own and actually hear an answer to this diagnostic scenario question that's in the textbook from an expert in the field. And so Scott Brown and I sat down, we did those together. And I think that's another, it's a unique feature that that we have at Goodheart-Willcox that isn't in any other products, but that's something that we put together as another way to help your students, you know, hear those answers and things like that. So that is our overview of the maintenance and light repair technician update that we have. Yeah, go ahead.
It doesn't look like we have any questions in the chat, but if you guys have any questions from this webinar, feel free to leave them in the Q&A or questions, or if you think of anything, you can always email me at jcarlson at g-w.com. And then while you guys are thinking of questions too, if you guys need a certificate of participation, you could email that email on the screen as well, and we can send that your way.
Yeah, thanks, Josh. I'm also noticing that Abby did put an example of a diagnostic scenario question there in the chat as well, so you can take a look at that. But that's something that, yeah, Scott Brown and I worked on that, and that was actually I really enjoyed doing that and working with him to put together those answers. You know, I will say with Goodheart-Willcox, they started out with, I don't know if anybody has it. I have a copy of it. Not right here with me, but Goodheart-Willcox started out over 100 years ago, probably 101 years ago now, with an automotive encyclopedia that Goodheart-Willcox published, and that was their very first publication as a publishing company out of Tinley Park, Chicago, Illinois area, and their only focus, Goodheart-Willcox's only focus, is on career and technical education products. So they specialize in vocational education, in career and technical education. I have to say, so my kids, my daughter is actually going into high school next year, and we did the high school showcase event where we went to the high school here in Austin, Texas, and we visited all of the the programs that they offer, and it made me really excited because she was super excited about the animal science programs and being part of FFA and like also ASL, American Sign Language, all this stuff, and she's like, she's really passionate about that type of stuff, and that's really exciting for me because those are the colleagues that we have, right? Those are the other the other shop teachers essentially that we work with every day. And so knowing that, and then the same thing, the middle school that my son's going to be going to has construction trades and has like an introduction to engineering type programs. And those are the two things that he's the most excited about. So it really is important. And I'm really excited that both of my kids are like, they're drawn to these like hands-on school offerings that are offered out there. So that's really exciting, for me as a parent to see that with my kids and to know that that's something that I was part of as an instructor, always trying to recruit kids into my program, and to see them go out there and do that. And then, just knowing that we have great publishers like Goodheart-Willcox out there. It's an American-made product. Everything is done right here, in the U.S. All the authors, everybody that works on all these products. So, that's what you support when you think about working with Goodheart-Willcox. It'll be 10 years in May for me with working with them, helping develop stuff, and everybody there is great professionals, really great products and stuff like that. So,
it looks like we do have a question in the
okay.
Q&A.
Yeah.
How do you recommend splitting students into groups when they work in a shop? And how do you make sure each student is mastering the skills within the group?
Yeah, those are good questions. So a lot of times if you let students sort of divide themselves up, they're going to stick with their friends. And so whenever I was doing classroom management with the high school, I would create groups that the students would be like their shop groups that they would work with. And I would do that, sort of randomly so that they weren't always just working with their friends. I think mixing those groups up does help the students develop a little bit better and grow a little bit better. And then I would also, if one of the things that you can do kind of as an exercise with your students is create different roles within a group and explain to them when they're doing group work that different roles are going to emerge, right? Somebody's going to be more of like a leader. Somebody's going to be more of like a note taker. Somebody's going to be the person who's like getting all the tools and stuff organized. And somebody else is going to be, maybe somebody who's going to be the one who's going to go ask the questions to the teacher type of thing. So there's different roles within a group. So I think if you set that up with your students from the beginning and you talk about that, then they start to sort of naturally take those roles as you get them into the shop. In terms of assessing them, I think the way that I was handling it was that I would, when a group was kind of like at a checkpoint, and that's actually something that we have built into the system, is like instructor checkpoints, where they're basically, it says, bring the instructor over so that they can then ask you some questions. And what we did as the instructor resources is we actually wrote out several instructor checkpoint questions that you can ask. So you don't even have to think of the questions to ask. We have a resource that shows you different checkpoint questions to ask the students to gauge their understanding. And this is what gets us back to that like fender side lecture, right? So if you've got maybe 3 or 4 students working together on a vehicle, and then they call you over and you are, asking them different questions, that's your opportunity as an instructor to sort of like really test each individual and like, all right, I'm going to ask this question to you and I want, your response, and then jump to the other person, ask them another question, and start to try to gauge each person's, level of response, level of understanding. That's one of the strategies. Obviously at the end, they're all going to have to like take their own tests. So they're all going to have to like answer the questions on the test. But for that shop work and that group work, I think that's one of the things that, that does help. It also does help to change the groups up after a while too, so that they don't get, too comfortable in that role because maybe somebody else is dominating a role that they would want to take. So I do think it helps, from a classroom management standpoint, set the expectations of how group work is going to happen, what those different roles are, but then mix the groups up a little bit. Hopefully that that answers that question for you.
Yeah, it doesn't look like we have anything else. However, you may have seen this in the chat, but we are offering, for anybody that attended today, you're welcome to ask for a free sample of either title. So feel free to put it in the chat and we will get back to you shortly on that. And yeah, thank you everybody for attending today. We really appreciate your time. And then there'll be this presentation of the recording and the presentation slides will be available to you, and we will email that to you shortly as well. So thank you everybody for attending, and have a good one.